Okay, so this is part 2 of the 5. Oops, it went forward. We need to do this one still. But this is the 5.3.2 quiz review. And this is part 2. Okay, just keep that in mind. It says for a stunt plane traveling at a speed of 320 kilometers per hour, what is the minimum radius of downward arc that a pilot can fly without blood being forced up into his head at the top of the arc? The centripetal acceleration at which blood is forced up into the head is 2.5 times gravity. So let's find some things out. The first thing we need to do is convert this to meters per second. So we have 320 kilometers per hour. 1 kilometer is equal to 1,000 meters. And then we have to do our time, 1 hour, 60 minutes. 1 minute is 60 seconds. And then, so let's see, that one and that one, this one, we end up with meters per second. So when you multiply and divide all of that out, you should get this, okay? And then the acceleration that we're trying to keep from happening, I don't think I ever used that. So what I have is acceleration minus gravity has to be less than 2.5 times g, which is my kind of threshold centripetal acceleration. So what I did was I'm solving for this. I went ahead and added g across. So I end up with acceleration has to be less than 3.5 g. So acceleration has to be less than 3.5 times 9.8, which is equal to 34.3 meters per second squared. Now, I'm going to use this formula. I'm going to plug this in here. And I'm going to plug this in here. All over r. And I'm solving for r. So I end up with 230.36 meters. And that's my answer. Okay, a Ferris wheel has a diameter of 60 meters. So if the diameter is 60, I know the radius is 30. And a period of rotation of 70 seconds. A passenger weighs, so this is my force of weight, is equal to 500, so, which is also equal to mass times gravity. What is her apparent weight at the highest point of the Ferris wheel? So I used the dynamics of a Ferris wheel. Right, it's on page 7 of 30 in the lesson. So, let's see. Let's make this I have force normal, and I have force at the weight. Velocity is equal to 2 pi r over t, which is 2 times 3.14 times 30 over 70, which is equal to 2.69 meters per second. And I know that the sum of the forces is equal to mass times acceleration, so I know that my force normal minus my force of weight is equal to mass times acceleration. This is at the top of the Ferris wheel. So force normal minus mg is equal to m v squared over r. And I'm solving for force normal. So I get m v squared over r plus mg. I used this to to find her mass. So this is 500 is equal to mass times 9.8. So her mass is 51.02 kilograms. So I'm going to plug that in. So I get, I see what I did. The other thing is, it's, so this is directional. This is going to be this. There's this. Acceleration should be towards the center. But that should be directional. So I end up with 2.69 squared over 70, my bad, 30, plus, and this is 500, so the only thing I need my mass for is this one. But once you figure this out and make sure you have this directional negative here, you should get this, which is C. Okay, another Ferris wheel with a diameter of 90. So the diameter is 90. The radius is going to be 45. Rotation, 65 seconds. Force of weight is 300 newtons. This is at the lowest point. And you'll find the direction is going to be different for F equals ma on this one. So what I did was I have my person, my force normal, my force of weight, and my force ma or ma. Actually, I guess I don't need. Anyway. So I found velocity, which is 2 pi r over t, which is 2 times 3.14 times 45 over 65, which is 4.34. Yeah, I think this should have gone this way. Here. Anywho, let's go back to our problem. That's 4.34 meters per second. So I have force normal is equal to my force of weight plus mass times acceleration. So force normal is equal to mg plus mv squared over r. So this is 300 plus, I have to find her weight, or her mass. So this is mg is equal to 300, which is m times 9.8 is equal to 300. M is equal to 30.6 kilograms. So this is 30.6 times 4.34 squared over 45. And I get 312.8 newtons, which is this one. Okay. I think this is the last one for this. A little girl is walking. She's swinging her arms through a 20-degree angle every 0.25 seconds. The length of her arm is 30 centimeters. Assuming the arms move with constant speed during the swing, what is the force that her arm would exert on 1 gram drop of blood? Okay, that's a little bit creepy, but okay. It's equal to, we have to make this into kilograms. My radius is 30 centimeters, and I have to make that into meters. We have time is equal to 0.25 seconds. And then 20 degrees is equal to 1/18 of a circle, and that's in the example. Oh, what did I do wrong? Oh, you don't need any of that. This is all you need. Check this. Okay, you're looking for force. You have your mass. This is your answer. You don't need any of this. You just need mass times gravity. It's a simple case of too much information, because this is the answer. Okay. All right. Let me know if you have any questions.